Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to write polynomial functions with given zeros. Before we get started, let's do a real quick review on some key formulas, theorems, and a definition that will help us with the problem solving process. Okay, so let's do the following review. So some formulas you want to keep in mind. The first one is the difference of squares formula. The difference of squares formula helps you to factor a difference of squares. So if you have a squared minus b squared, the factored form of this is simply a plus b times a minus b. Okay, you just take the square root of the squares and express the roots as a sum quantity and a difference quantity. The next formula is known as the square of a sum formula, and that's given by a plus b quantity square. If you expand this, what you get is a square plus 2ab plus b square. Now what if you have the square of a difference? This is not difference of squares, okay? The difference of squares is different from the square of a difference. The square of a difference is a minus b quantity square, and is not equal to a square minus b square. It is equal to a square minus 2ab plus b square. Okay? So the beauty of these two formulas, the square of a sum and the square of a difference, is that it enables you to factor binomials that are squared quickly. Okay? Alright. And then the theorem we would like to keep in mind is the irrational roots theorem. The irrational roots theorem is as follows. So if a plus root b is a root of some polynomial, let's call it f of x, then guess what? Then a minus root b, the conjugate of this irrational root, is also a root. Okay, is also a root of f of x as long as there's a condition f of x has integer coefficients. Okay, has integral coefficients. If you think about your quadratic formula, for example, you remember the plus or minus component there. That's basically showing you the irrational roots. So for example, if you have root 3 as a root of a polynomial with integer coefficients, its conjugate negative root 3 is also a root. Or if you have 5 minus 2 root 7 as a root, then a conjugate 5 plus 2 root 7 will also be a root. You find the conjugate by taking the opposite of the irrational piece of your rational number, the radical piece. Okay, so in this case, you just take the opposite of root 3, which is negative root 3. In this part, you take the opposite of negative 2 root 7, which is positive 2 root 7. Okay, so that's that for the irrational roots theorem. And then lastly, you need to know what the word or the term multiplicity means. Okay, so if you're given a particular root or zero with multiplicity, what does that tell you? The multiplicity is the number of times the roots or zeros of a polynomial function or equation occurs. Okay, so the multiplicity is the number of times, let's just go with roots, the number of times a root of a polynomial occurs. Okay, so that's the whole idea of multiplicity. Okay, now let's take a look at this example here. Instructions are for us to write the polynomial function of least degree and integral coefficients with the given zeros. So we have a polynomial function that the zeros are 0, negative 2/3, with a multiplicity of 2 and 3 minus root 2. Okay, so let's list our zeros. We have x equals 0 as one of the zeros, x equals negative 2/3 as another zero, but it has a multiplicity of 2, so it occurs twice. We'll write it twice. And then we have x equals 3 minus root 2. This is an irrational root, so its conjugate must also be a root of that polynomial. So guess what? We're going to add an x equals 3 plus, let me highlight the color here, 3 plus root 2. Okay, so to get the conjugate of an irrational number, you simply negate the radical piece. And there you have it. Alright, now what we're going to do is we're going to set each equation equal to 0, so we can use the reversal of the zero product property. Okay, so this is already equal to 0. That's good. Now, for this one right here, we can simply add 2/3 to both sides. But upon expansion, we're going to violate the requirement that it has integral coefficients. Is going to have, I might end up having fractional coefficients. Okay, we do not want that. So to ensure that we do not have integral coefficients, we need to set this equal to 0 in such a way that there are no fractions involved. To accomplish that, we'll first multiply by 3. So that gives us 3x minus equals negative 2. Okay, and then you add 2 to both sides and you have the desired state, 3x plus 2 equals 0. No fractional terms here. Perfect. The same process applies to this. Since they're identical, it will also be 3x plus 2 equals 0. Now, these irrational roots here, we're going to use some shortcuts to really help us to generate the expanded form when we're multiplying, because it could be really complicated if we don't approach the expansion of these roots with care. Alright? So what we're going to do is basically subtract the irrational number as a whole from both sides. Okay, so let's group them in parentheses. And then we're going to subtract them as a package from both sides with the goal of setting it equal to 0. So from the left side, we're going to subtract quantity 3 minus root 2. And then here, subtract quantity 3 minus root 2. That yields x minus the quantity 3 minus root 2 equals 0. On the right side here, we're going to do exactly the same thing, but we're subtracting 3 plus root 2 from both sides. Subtract the quantity 3 plus root 2. And then that yields x minus the quantity 3 plus root 2 equals 0. Okay? Now that we have all of them equal to 0, we're going to use the reversal of the zero product property to express them as a product of quantities that is equal to 0. Okay? So if we do that, we're going to get x times the quantity 3x plus 2 times the quantity 3x plus 2 times x minus the quantity 3 minus root 2 times x minus the quantity 3 plus root 2 equals to 0. Okay, so now that we have it in this format, our goal is to expand this completely to generate the polynomial function with these rational roots. Okay, not irrational, I mean with these roots. Some of them are rational, this one is not. Okay, so let's go ahead and start. Now, I'm just going to bring down this x for a minute and then express this as 3x plus 2 square since it's being multiplied by itself. I'm going to use the associative property to rewrite this as quantity x minus 3 minus root 2. And then here we reorient using the associative property. Here we rewrite it as x minus 3 plus root 2. So you might wonder, why are we doing this? We'll talk about that in a second. If you take a look at this piece right here, 3x plus 2 squared, remember the formula we talked about earlier? Let's refresh our memories. We talked about the square of a sum. So a plus b, if you take the square of a sum, is going to be a squared plus 2ab plus b squared. Now, if you do not like this formula, you can multiply 3x plus 2 by itself and FOIL that out. You will get the same answer. I'm just using shortcuts to accelerate the computational process. So we're going to have x and then 3x plus 2. Let's list what we have out from here. 3x is our a, and b is 2. Alright, so keep that in mind. A squared is going to be 9x squared plus 2ab is plus 2 times 3x times 2, which is 12x, plus b squared, which is 4. Okay, so that's that. Now, let's take a look at what we have here. You notice that I reassociated the terms that are being subtracted here, and here we have a difference and a sum. Why did I do that? Well, it enables us to take advantage of the difference of squares formula. If you have a minus b times a plus b, what does that become? That's a squared minus b squared. This is the factored state of a difference of squares. This is the expanded form. Ladies and gentlemen, we have the expanded form, the factored form of a difference of squares. So we're going to expand it. Upon expansion, the middle terms will cancel out because it's in this format. We'll end up with a squared minus b squared. In this particular setup, our a and b is not that obvious. In this setup, a is the quantity x minus 3, and b is the irrational number root 2. Alrighty? So we have a minus b, okay, being multiplied, so a minus b being multiplied with a, this entire quantity here, plus b, this number here. So what is a minus b times a plus b? A minus b times a plus b is a squared plus, a squared minus b squared. Okay? So if we apply the difference of squares formula, we're going to have a squared. What is a squared going to be? Remember, a is the quantity. Let me show it to you. X minus 3. Okay? So a squared is going to be x minus 3 squared. Minus b squared. B is root 2, right? So it's going to be root 2 squared. Okay? So this really hastens the computational process and also reduces the chances of making mistakes. Okay, so we have that right there. And now we're going to go ahead and expand further. If you have any questions on any part of this tutorial, just feel free to include your question in the comment section below, and we'll be more than glad to clarify. Alright, now let's continue. On the left side, we can distribute this x to all these terms here. So that yields 9x to the third plus 12x squared plus 4x. Okay, so we have this cubic trinomial here. Now, if you take a look at this, the expansion of this difference of squares, you will notice that we have another square here. This is the square of a difference. How do you expand the square of a difference? let's review that again. I showed you earlier, but let's just take a look at it. If you have a minus b, the square of a difference, not difference of squares, this is going to be a squared minus 2ab plus b squared. It's just like the square of a sum, but the difference is that the first sign is negative for the square of a difference. Okay? Alright, now let's apply that here. We have a minus b. So we're going to have a squared minus 2ab. So minus 2 times x times 3 is minus 6x. Plus b squared, 9. Minus b squared root 2 squared is just 2. Okay? Equals 0. Alright, now this looks much better than this scary equation we have up there. So we'll just simply multiply these two, but before we do that, I think we can simplify. So we have 9x to the third plus 12x squared plus 4x times x squared minus 6x plus 9 minus 2 is positive 7 equals 0. Okay, so we're going to multiply this cubic trinomial with this quadratic trinomial. Whenever I'm multiplying polynomials and we have 3 or more terms with one and the other is 2 or more terms, I like to make use of my box method. It's a nice way of organizing your product in such a way that you don't make mistakes. Okay? Okay, so our box has a dimension of 3 by 3. The reason why we have that dimension is because we are dealing with two trinomials. Okay? So each column or each row corresponds to a term of a polynomial. Let's put the first factor upstairs, so 9x squared. 9x squared plus 12x squared plus 4x. And then let's orient the second factor vertically. X squared is the first row, negative 6x is the second row, and 7 is the last row. So what we've created is a multiplication chart, table, or matrix, okay? So just like your old-fashioned multiplication table, that's what we have here, but we're going to be generating algebraic and numerical values. Okay, so let's do it. X squared times, well, this is 9x to the third. Change the problem there, so this is 9x raised to the third power. Okay, so when we multiply these two, we have 9x to the fifth. Remember your properties of exponents. When you multiply two exponents with the same base, you add the powers. Okay, 12x squared times 12x times x squared is 12x to the fourth. 4x times x squared is 4x to the third. 9x to the third times negative 6x is negative 54 x to the fourth power. And 12x squared times negative 6x is going to be negative 72x to the third. 4x times negative 6x is negative 24x squared. 9x cubed times 7 is 63x cubed. 12x squared times 7 is 84x squared. And then 4x times 7 is 28x. Okay? We're just going to combine like terms and that will be our final answer. So, what are we going to get? Let's start with the first one. We have 9x to the fifth power. This one is by itself, okay? There's nothing to combine this one with, so let's just bring that one down. We have 9x to the fifth power, so f of x equals 9x to the fifth power. And then you look at the degrees with the fourth degree terms. So this diagonal right here, bam, combine it. Okay, so what do we get? 12x to the fourth minus 54x to the fourth. If you subtract, you will end up with negative 42x to the fourth. Move on to the next diagonal. The cubes. The cubic terms, not cubes, the terms with the cubic degree, third degree terms. Okay, so if you combine those, you just go negative 72 minus negative 72 plus 67x to the third. Okay, so if you have negative 72 minus 67x to the third, you will just end up with negative 5. So we have negative 5x to the third, almost there, and then we have the squares. Okay, the second degree terms, if you combine these two together, what do we get? We get negative 24 plus 84. 84 minus 24 is 60, so positive 60x squared. And then the last term is just 28x, so plus 28x. There goes our final answer. Let's go ahead and box that. So what have we just done so far? What we've done is we've created the function. If you solve this function, what you end up with is you end up with 5 roots, which are 0, negative 2/3 twice, and then 3 minus root 2 and 3 plus root 2. Okay, so what we did is we basically worked backwards from the zeros or solutions or x-intercepts of a polynomial function, and we generated the polynomial function that has those zeros when solved. Okay, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful to you in your study of polynomial functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we went over in this tutorial, or any pre-calc questions in general, just place your questions in the comments section below, and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.